Hello everyone, it's Teacher Sunny here again. Today, I'm going to talk to you about another interesting problem involving quantity-rate correspondence. In my previous videos, I have already mentioned that as long as you truly master two fundamental ways of thinking, then for most problems, indeed, over 80% of them, you'll be able to solve them quite easily. Do you still clearly remember what those two fundamental ways of thinking are? The first one is the crucial concept of quantity-rate correspondence, and the second one, of course, it's an equivalent substitution. As long as you fully master these two concepts, even complex word problems will become a breeze. Additionally, Teacher Sunny is also the only teacher in Malaysia who teach how to solve problems by drawing diagrams. Solving problems is indeed like an upgraded or even a very superior version of CPA. This is actually the teaching approach I really use. Alright, let's then get back to the main topic. We'll simply use this problem as an example to explain it in detail to everyone here. Alright, let's first analyze the problem. A clothing factory produces a batch of suits over 20 days. The ratio of completed to uncompleted suits is 1 to 2. If another 600 suits are produced, the number of completed suits will be 1/3 less than the number of uncompleted suits. How many suits are there in total in this batch? Alright, when we first read this particular problem, many students often get quite confused, right? Because there are indeed a lot of parameters and a significant number of changes involved in it, making it genuinely hard to clearly distinguish between various things. That's precisely why the crucial step of analyzing the problem statement is exceptionally important. In our previous videos, Teacher Sunny has also consistently emphasized that thoroughly analyzing the problem is truly half the battle to success. Alright, let's take a look. Here it says produced for 20 days. Actually, these 20 days are just there to distract you. They're not important and can be ignored here. So, which part is important? It's the relationship between what's completed and what's not completed. So first we see that the ratio of completed to uncompleted sets is 1 to 2. That is to say, the number you've completed, the number of sets completed compared to the number of sets not yet completed. The ratio in this particular instance is precisely 1 to 2. So what does this truly and fundamentally mean? In other words, what is the total number of sets? The total number of sets is the number of completed sets plus the number of uncompleted sets. From this 1 to 2 ratio, we know that the completed sets account for 1 part and the uncompleted sets account for 2 parts. So altogether, that's 3 parts in total. This is the completed portion. The completed portion accounts for 1 part, and this is the uncompleted portion, the number of sets that accounts for 2 parts. Now, this makes it really clear, right? Next, the question tells us that if 600 sets are produced, so if 600 sets are produced, it's obvious that these 600 sets are the completed sets. Right? These 600 sets are the ones you've completed. So what changes after producing 600 sets? At this point, the number of completed sets is 1/3 less than the number of uncompleted sets. So what exactly do we do indeed? We can make a direct comparison, that is to say, the completed sets compared to the uncompleted ones. As for the ratio, we can just use comparative thinking directly. Here, the completed sets are 1/3 less than the uncompleted ones. So, what about the uncompleted sets? There are a total of 3 parts in total. Therefore, when compared to the 3 parts of the uncompleted sets, it's missing 1 part, not just 1 part, but out of 3 parts, it's missing 1. So the completed sets actually make up 2 parts. Yes, the completed sets actually account for 2 parts. So that means after adding 600 completed sets, what's the new total number of sets in all altogether? It's 5 parts. This way it's much easier to understand. So here we have 3 distinct parts, and here we have 5 total parts. Of these, precisely 2 parts are the number of completed sets, and 3 parts are the number of uncompleted sets. So now it's very clear. What's next precisely? Oh, we just simply need to set up a proportional relationship to accurately calculate how many suits are actually in this particular batch. And to set up this proportional relationship, what exactly do we really need to do? That is, let's list out all of the invariant equalities and then also carefully list out all of the variable equalities. This way we can effectively set up the proportional relationship. Alright, let's see. What exactly is the invariant here? Is the number of completed sets the invariant? Or is it the number of uncompleted sets that's the invariant? Let's look here. The key is right here. Plus, add the production of 600 more sets. These have already been produced, so they count as completed sets. In other words, the number of uncompleted sets actually hasn't changed. So that means the total number of uncompleted sets represented by the two triangles here, and after carefully adding the 600 completed sets here, the number of uncompleted sets on this particular side is 3 distinct parts. So in other words, the fundamental invariant is the number of uncompleted sets. 2 triangles are indeed equal to 3 triangles, right? This division, this separation remains precisely the same. Yes, this separation is exactly the same. So in this specific case, let's look again very closely. Its variable. What is the relationship of equality for the variable? It's the number of completed sets. So, for the completed sets, we can see here that the number of completed sets starts with 1 set, then adds 600 completed sets. So in the end, it equals, over here, 2 parts, which means plus 600 sets. So we've already thoroughly described both the invariant and the variable relationships of equality here. Next, we will carefully use the specific method that precisely corresponds to the bright green section. First, we accurately put the quantity in front, and then, for the distinct green part, we consider the 2 prominent circles, specifically the separated part of the circle, and then subtract from this the triangular part. Alright, so here, this is indeed Unit 1. This specific part is clearly identified as Unit 1. Alright, let's consider and take this particular section as the designated unit, okay? The quantity is 600 divided by the fraction. As for the fraction, the 2 parts of the circle are equal to 2 out of 3 parts on this side. So it's 2/3 minus 1 part of the triangle here. On this side, it's 1 part out of 2 parts of the triangle, which means it's 1 out of 2, or 1/2. So this value actually equals precisely 600 indeed. 4 minus 3 and 1/6, then divided by 1/6 is the same as multiplying by 6, which is 3,600. So that means the unit here is 3,600. So the unit here is 3,600. Now, if the unit is indeed 3,600, how many suits are there in this particular batch? That is to say, before any changes were made, how many suits were there in total? There are 3 distinct parts represented by triangles, right? 3 triangles. So that means 2 triangles are indeed equal to 3,600, or alternatively, 3 circles are also equal to 3,600. However, we just need to specifically find the value of the triangles, because at the very beginning of this particular problem, this entire batch of suits produced is clearly represented by 3 distinct triangles. So that truly means one single triangle is equal to 3,600 divided between 2 triangles. In other words, one triangle is precisely equal to 1,800. Alright, so just 1,800. Exactly then, finally. What about the total amount? For this particular batch of suits originally, there are 3 distinct triangles, which means 1,800 times 3 triangles equals 5,400 suits. This way we can solve it. Have you learned it? So please give Teacher Sunny a like and follow, and don't hesitate to use your little hands to share this with more people so we can all learn together. The more people who learn, the more Teacher Sunny will share.